Hello students, welcome back to my channel. In today's session, we are learning another algorithm which is finding the maximum number in a set. This is a very simple and very basic algorithm. Let us see what is the problem statement is. The problem statement tells us to find a maximum number in an array of n elements. Okay, so as you can see here, given any array in any order, we should be able to find out the element which has the maximum value. All right, so let us go ahead and see the algorithm. So here I'm going to start with an array, and then the n value is always greater than or equal to 1. That means I have at least one element. And then I'm going to declare array n and I. Okay, so now read n elements of array and store the elements in an array. So let's suppose I'm reading the element. So let me just read the element. I will say 23, 4, 1, 99 and 5. These are my elements and my n value is 5. All right. So set first array element as temporary maximum max. So what I'm going to do is I'm going to take this, the very first element, as a maximum value initially. Okay. So I'm going to say max is equals to a of 0. So this is the 0, 1, 2, 3, 4. So max is going to get this, this a is the name of the array. Max is going to get a of 0, which is nothing but 23. And then I'm going to initialize I is equals to 1. Now, while I is less than n, now we are going to check through all these elements. That is the reason I is being initialized with 1s, which means I is over here until I becomes less than the n value. What we are going to do is, if the next array element a of I is greater than the current maximum, then max is equal to ai. It is very simple. So what I'm going to do is, I am going to now take a loop where I have taken I value, and then I'm going to loop through the rest of the values, and then I'm going to compare whether this value is less than any of this. The moment I find a value which is greater than the maximum value, I'm simply going to swap. That is, in the max, I'm going to store that value. So let us begin. So I is now 1. So I'm going to compare 23 and 4. And of course, as you can see, still 23 itself is the maximum. Hence, I'm not going to change. I'm simply going to increment the I value to 2. Once again, I will compare 23 and 1. And here also what is going to happen? 23 is still the maximum value. Hence, I'm not going to swap the maximum value. I'll just increment the I value. Okay, the code for that is written here. If the next array element A of I is greater than the maximum, then only we are going to swap the value. That is, maximum value will change. Otherwise, simply we will increment the I value. All right, so I is at 3 now. Now I have the value 99. Now I'm comparing whether 23 is greater than 99. But no, in this case, we have a different situation where now 99 is greater. So in that case, what I'm going to do, I'm going to execute this. Now maximum value is going to get a of I value is 3. Hence, maximum is going to be 99. All right. After that, once again, we have to loop because we never know. We might get 100 next. We cannot stop it here. Okay, so I'm going to increment the I value over here, and then I'll get 5. I'm going to compare whether 5 is greater than 99, which is not. Hence, I'm going to continue incrementing the I value. But here, what is going to happen? Now, I value is going to be greater than n. Okay, so considering so this we can also say I is equal to I is less than or equal to n. So what is going to happen? I value is becoming equal to n, and hence I am going to stop the loop. Okay, then we have found our maximum value at 90. All right, so it's a very simple logic. I hope it is clear. So all I am doing is I will take values. I will take the initial value as a maximum. I will keep a counter. I compare. If this value is greater, then swap it. Otherwise, simply increment the I value until you complete looping through the rest of the element apart from the first element. That's all is the logic here. I hope this is clear. So that's all in today's session, students. Thank you for watching. Keep learning.